I'm going to be talking more about the so if you take these kinds of lightweight environments that he described that were built using Stitcher and such systems, what do they look like on Kubernetes? So I'm going to first sort of go into why fundamentally we need such ways of doing environments, and then step a little bit into um, yeah, how such a system can be built on Kubernetes. Like, what are the different considerations? What are the different aspects of the solution? Um, yeah, a little bit about me. I'm the CTO and co-founder of Signadot. Um, yeah, I think Arjun mentioned this. Prior to this, I was working on Kubernetes at Google, and then yeah, built some of the workload controllers and things. At Signadot, we primarily focus on building these kinds of lightweight environments and making them sort of Kubernetes native and making them available on Kubernetes. So traditional approaches to environments, and this might actually tie into one of the Q&A questions, maybe. Uh, so traditionally, what I've seen is there is different sets of environments which all serve different purposes. So you have dev environments, which are typically low fidelity. The whole focus is around quickly, uh, testing something quickly, being able to manipulate whatever data you want, etc. These could be like Minikube, Docker Compose, etc. The focus is not on having every single dependency and every like cloud database connected to it and so on. It's more on just like getting something working. But universally, what we see is like as the number of microservices grows, like even beyond 20, you need like the need for high fidelity environments, which are more close to production, becomes higher because there are so many like cloud databases, third-party APIs, etc. So more and more of that uh, testing becomes possible only in environments which are close to production, so pre-production environments. Um, and then if you look at the traditional approaches, like if you take either deploying a whole namespace with every single service in it or a separate cluster with every single service in it, there are limitations of that, especially when you scale. So one of them is like the infrastructure cost and the operational burden is like scaling almost yeah, it's like number of microservices times the number of environments, right? So as you have more development teams, et cetera, this is going to just keep going up. And then one more sort of subtle issue that comes up when you have many environments is that there's different versions of things running in different environments. So even if you were to test everything against one of those environments, it is still not representative because by then somebody might have committed changes to one of the microservices that you were using as a dependency. So that test is no longer valid. And we've seen creative solutions to this, like some people kind of timeshare the pre-prod environment. You have one team using one staging environment or something like that. So there's lots of workarounds, but either they incur a lot of cost or they slow down the dev process because they're bottlenecks all the time. So this is where slice-based environments come in. So this is similar to what Fortis described with Stitcher. The fundamental idea is that you have a shared pool of dependencies which are constantly being updated. So these updates are coming from the main branch or the master branch. So those are running the stable versions of the microservices. And then your changes are the only things you're deploying into it and then sort of stitching them together to realize your environment. So like this, for example, represents a baseline environment. So this is just a representative microservice stack. You have a couple of services, and then they're like, yeah, they're being constantly updated from master, let's say. So a slice could be something that's in a branch somewhere or a pull request or something, which contains a test version of service one. And you can see the yellow path taken by the request. So that's what, if you were to address the slice in some way and tell the request to follow the path of slice one, then it would follow the yellow path as opposed to the original black one. And you can do this as many times as you want with different sets of microservices, including like isolating state, like Fortis was mentioning, and so on and so forth. So it's possible to then have all of these, like this is three separate environments in some sense, because you're realizing each of these request flows in isolation from each other. So stepping a bit into like such solutions, like aside from Stitcher, they've also been built for environments at scale in other companies. Not all of these were built on Kubernetes, but we've seen like DoorDash, Lyft, and Uber actually build out internal solutions that look similar to this, which are relying on this notion of an environment slice in order to do testing. Um, so this is the point at which, yeah, I'll switch over to sort of going into the details of what it takes to build such an environment inside of Kubernetes. Like, what are the different aspects, how to think about them, what are some considerations and design choices in them. So starting with how we define and deploy these workloads. So if you saw that larger environment, like over here, we're always deploying one or more services into a slice, which is, you could either say, okay, this is part of my CI/CD process and I'm going to deploy it the same way, or you could choose a different approach for it. So that's what this is about, like actually getting the Kubernetes service into the cluster, the test version of it. So the first option here is, okay, let's just take the entire YAML specification of the service, push it into the cluster, and maybe store it somewhere. Like, maybe do we put it into Git? Do we store it sort of like, do we template the baseline deployment so that we can realize test versions that way? So that's one way to do it. What we found in practice was that when it comes to test workloads, most of the time there's only a few things that are changing, and the long tail of use cases is everything else changing. Like, it's very uncommon to have a test workload that is completely like different in every single way when it comes to configuration from the baseline. So an efficient way to describe a test workload becomes, if you're familiar with customize with a K, that sort of format. So this is like a format that we chose to design with. And it's like you specify what it is a fork of. So you're referencing a runtime deployment in Kubernetes, and then you're saying what has changed. So customizations is just what changed. So you could be, most commonly it's like images and environment variables, but it could very well be a bunch of other things with a custom patch and so on. So this, one of the advantages of specifying this declaratively is also that any changes that happen to the baseline also get reflected in this test version of the workload, because the test version is derived from the baseline. So you don't have to necessarily go and update n different deployments when the baseline is updated. So this is part one. The other piece here, which Fortis also mentioned, was stateful resources. So you're going to have databases, message queues, things like that, which may need additional isolation. So those, it may not be possible to like isolate them at the request level. So for that, you would also need a way to deploy these ephemeral stateful resources alongside the slice. So take an environment slice, you have one of the Kubernetes workloads inside of it. You can also deploy something else, like a database that has been seeded with some data, or a message queue that it needs to talk to into that same slice. So the key consideration here is, um, you want to tie it to the lifecycle so that when the slice goes away, the resource also gets cleaned up. And you also want to think about whether you need the level of isolation at the infrastructure level. So traditional environments, you would be isolating everything at the infrastructure level, right? So there's no question there. But here you have a choice. Like, if the data store or the message queue offers some notion of tenancy, that is offering logical isolation, that would be preferable because that's a much more lightweight mechanism. So concretely, that would be taking a Kafka topic and associating that with a slice, as opposed to an entire Kafka cluster containing Zookeeper and whatnot. So there's some considerations there about at what level you want to isolate. But the key thing here is those resources would come up as part of your slice, and then you would supply those credentials back to your workload so that those two can be tied together, and that slice is sort of self-contained. So that's the goal here with this. Um, then we get to the second part of this, which is we were talking about all that request routing that was happening, right? So um, there's two different parts to it. So one is, how does the request actually know uh, which flow it belongs to? Like this one, let's say it's tagged as routing key K1, that needs to persist all the way through this chain so that a local routing decision can be made to send requests to the test workload instead of the baseline workload. So that is the easiest way to do that is through request headers. And thanks to projects like OpenTelemetry, this is actually really easy. So there is a W3C standard that has trace state and trace state and baggage headers, which are well supported in OpenTelemetry. So in a lot of languages, it's possible to just add the library and get this behavior for free without doing anything additional. In some cases, it requires like reading the request on the incoming side and then pushing that routing key or like pushing that context to the outgoing side. So we are in this case like it would be using some primitives that are coming from tracing, but the tracing backend itself is not needed. The only thing that's needed is for every request coming into the service to persist this context of routing key K1 as it passes the request along to the next service in the chain. Uh, and of course, like one of the special cases, like if you're talking to an external service, like we've seen this with PubSub, for example, um, the service might not support headers. So in that case, you would use a query parameter in order to uh, achieve the same sort of context, like preserving this context all through the chain. And finally, the last part of this, we come to how does the actual routing occur? So this is a much more local decision because at every service, you want to potentially make a decision of whether to reroute that request to a test workload or to continue and send it across to the baseline. So there's many approaches. All of them have advantages and disadvantages. So sidecars is probably the easiest of them all. So a sidecar container is like a pattern in Kubernetes where you can have uh, a container that is running alongside your main workload that can do things like network policy. So um, adding such a sidecar container can help you intercept that request and make that routing decision. So that's one way. If you're using Istio or like some sort of service mesh, then the service mesh itself can be taught to route those requests. So that's another way to do it. And of course, there's for really performance sensitive folks, there's also the option of like doing it in the application layer itself. So using like the L7 protocol interceptors, like HTTP and gRPC interceptors to make this routing decision. So it really depends which one people use, but generally speaking, the sidecar container route is the easiest to adopt when going into this kind of solution, unless you have a mesh, of course. Um, so yeah, so we talked about all of these slice-based environments. Now, like, what does this enable? Like, why do it? I think one of the like a couple of key things is like to be able to make a backend change, no matter how deep it is in your stack, and be able to test that from the front end, like at any point in time. So that's something that's enabled by this. So you have full confidence before you merge code that your feature does what you think it should. It like Fortis alluded to, it's also possible to have multiple such slices work together. So you can have a feature that spans different microservices and combine them together into one sort of routing context and send requests through both of them. So that's one way to realize like cross-service testing before pushing things to staging or some shared environment, like or without having to do things like feature flagging just for that. And of course, like because it is so lightweight to spin up, we're talking like under 30 seconds typically if you're for most cases, then it becomes cost effective to even do like testing at scale, like spinning up an environment just to run a few integration tests and running them against real environments, or just having all sorts of environments like I think Fortis also mentioned like demo environments, etc. So all of these become possible and really inexpensive to do with this model. So I'll pause here and then we can do the other poll where we wanted to ask you all about feature testing. Arjun, could you put that up? So here, feature testing refers to like a feature that spans multiple microservices that may be living in different repositories even. Interesting. Okay. So merging them independently uh, seems like the winner, but actually no, there's two of them which are kind of close. Spinning up an isolated environment and merging independently. Makes sense. Yeah, so it becomes possible to do these things sort of anywhere in your dev workflow and make them really, really inexpensive to do. So that speeds up the development lifecycle considerably. And of course, at the end, like where does Signadot fit into all of this? Like we have an implementation of these slice-based environments that we call sandboxes. So we make use of a Kubernetes operator that actually performs this operation of like defining the workload, etc. Have a sort of extensible resource plugin framework where you can specify what resources should be spun up as part of this slice. And I think Fortis mentioned, there's a lot of the DevX really matters. So that's why there are APIs, SDKs, and a bunch of other integration layers that allow for a very seamless experience when you're using these slice environments. So yeah, that's all I had. Thank you so much.